How are we doing today? Doing good, I hope. I have put the link in the chat box for those that need it. So we need to go ahead and open our Pear Deck box, as well as the document that's right here, because we will be using it today to do our notes. This is the same document we will use today and tomorrow. So go ahead and open it and answer your question. Alrighty, so our question today, it's a two-part question. First part is, how are changes in population related to the availability of an ecosystem's resource? And how many people, the second part is, many people want to live in an urban area. One of the main factors that limit is the number of people that can live in the area is what? All right, so things that I am seeing in the chat. I'm seeing um, I'm seeing that because more organisms live in an area, there are less resources to go around. I like that answer for question one. Um, for number two, with the amount of housing or apartments can be an issue. Definitely housing can be an issue, as well as what else? The amount of food that's available is an issue. There are places that are considered food deserts that don't have fresh fruits and vegetables available to people, especially in certain metropolitan areas. So that could definitely be a problem. Um, Most of it is what I'm saying is housing, which is definitely an issue. Space is definitely a problem. Demand for foods, that could be that there are not a lot of grocery stores in the area. Um, okay, so we get the gist. Cool. So you do need the document. So if you have not opened the document, make sure that you go ahead and do that. Today we are going to talk about the different factors and relationships that are in ecosystems. Um, we will spend a large part of the day talking about those relationships, and then tomorrow we will talk about food webs, food chains, and how they interact in our different biomes around the world. Your presentation is set to student pace, so if you would prefer to go at your own pace, you may do that. All right, so let's get started. We have interactions that are happening around our planet all the time. And with these interactions, they happen between organisms and the other abiotic factors that are in their environment. So it could be the other animals that are there, or it could be the plants that are there. Those interactions can cause populations to change. They can either increase or they can decrease. Some of those things that can cause that could be some of the abiotic things that we talked about yesterday that are related to weather or catastrophic events. It could also be related to the amount of predators or that are in the area, or it could also even be human effects that are going on. If there's like new subdivisions or something being built, and they end up cutting down trees and kind of disturbing the ecosystem there, then that can cause our populations to change. Interactions can also cause the whole ecosystem to change. We looked at a video yesterday and last week about those wolves in Yellowstone, and we saw how the just adding the wolves began to change the ecosystem itself, not just the wolves and what they ate, but the whole ecosystem. So one thing that's very fragile with ecosystems is something that's called stability. And with stable environments or stable ecosystems, you usually have populations and resources within those populations that change at a very predictable manner. So you typically have uh, a direct relationship between food and food sources that are available in ecosystems and the other organisms that are there. In stable ecosystems, there is a healthy balance between predators and prey that are going on in those different ecosystems. So, predation itself is the interactions that species go through. They will either be considered a predator or they will be considered the prey. So predators are the ones that are kind of doing the hunting and they eat the prey. This relationship is healthy and needed within ecosystems because if they're not there, we talked about how different ecosystems would change if the resources were not checked. So it's kind of like checks and balances within even our judicial system. But it's just nature's form of checks and balances. The example in the picture is a lion that is eating a gazelle in the grassland. It's regulating the numbers of gazelles because the lions hunt them. And so that is our predation. With them, there is a big impact with our predation. The number of prey in a population increases, then the number of predators is also going to increase. So as long as they have, there's food to eat, for the most part, predators will stay there and continue to eat them. If the number of predators decreases, then the number of prey is going to increase because animals don't necessarily stop having babies. But if there is no one or no organism there to eat the prey, whether it's the baby organisms or it's the full-grown organisms, the number will continue to increase. It's the way that kind of happens. All right, so next we have competition. And with competition, this is where you have animals that are going to compete for other resources within that ecosystem. So it could be food, it could be shelter, it could be water, but it could also be mates, even within same species. So competition definitely happens within those ecosystems. The example on the screen is we looked at this picture yesterday. It's a picture of a zebra, and he's in the process of possibly getting eaten by that lion. But there's also a hyena and some vultures that are also looking at that food to eat. So they will be in competition with each other to eat the food. If you've never really watched like any of the big cat shows that are like on Discovery Channel or on like Animal Planet or anything like that, you will definitely see this competition and how it happens in the wild if you ever want to watch any of those. There's also some videos on YouTube, but they definitely compete for different resources. Also in the oceans, you have dolphins and whales and large fish that compete with each other to eat the smaller fish. So sometimes they fight, sometimes they don't, but it just depends on what the animal is. So we have the relationships we're going to look at today are known as symbiotic relationships. They are animals that are living together closely in an environment. So if we break down the word symbiotic, the prefix "sym" means same. It could be together or same time. We know that bio means life. It always does. And that is kind of what's going on with those relationships. So within those relationships, they can do one of two things. Either they can coexist, which means they exist in the same time, in the same place, or they can cooperate, which means that they kind of work together for a common end goal or a purpose. So either they can just live in the same place. That doesn't mean that they're not going to fight or there's not going to be issues, but they can live in the same place or they can work together to accomplish a goal. So we're going to watch a video. And after we watch this video, I want you to tell me in the Pear Deck box, is the organism benefiting or is it being harmed?
Incredibly, 80% of all insects live in jungles. Few are more successful than the ants. There can be 8 million individuals in a single hectare. But jungle ants don't have it all their own way. These bullet ants are showing some worrying symptoms. Spores from a parasitic fungus called cordyceps have infiltrated their bodies and their minds. Its infected brain directs this ant upwards. Then, utterly disorientated, it grips a stem with its mandibles. Those afflicted that are discovered by the workers are quickly taken away and dumped far away from the colony. It seems extreme, but this is the reason why. Like something out of science fiction, the fruiting body of the cordyceps erupts from the ant's head. It can take 3 weeks to grow, and when finished, the deadly spores will burst from its tip. Then, any ant in the vicinity will be in serious risk of death. The fungus is so virulent, it can wipe out whole colonies of ants. And it's not just ants that fall victim to this killer. There are literally thousands of different types of cordyceps fungi, and remarkably, each specializes on just one species. But these attacks do have a positive effect on the jungle's diversity, since parasites like these stop any one group of animal getting the upper hand. The more numerous a species becomes, the more likely it will be attacked by its nemesis, a cordyceps fungus.
All right, so in the pear duck box, is the organism benefiting or is the organism being harmed? Which one? I will say I saw a whole bunch of ews and grosses that are popping up in the chat box. I will go ahead and prepare you guys. Our next unit, the microbe and disease unit, my favorite unit. But you guys are, if you're getting grossed out by that fungus, you're definitely going to get grossed out by the awesome pictures and videos that we are going to watch with our parasites and fungus and bacteria and all that good jazz that's coming up in our next one. I don't know if you guys remember, but when you guys are probably going to electives and probably from lunch. Oh, was that? Did we do that yet? I think we might have just been getting done with those. So before we went out on quarantine last year, there were posters that lined the hallways by the cafeteria, that everybody, like all kinds of people, thought they were just gross, and I can't believe you put them up. That were a bunch of different parasites and infectious diseases and all the rest of that. That is the unit that we're about to start. And yes, if we were in school, you guys would definitely make those posters, and they would be hanging up on the wall to gross everybody out. It's kind of a eighth grade tradition. But if you saw them, if you went there sixth grade, you definitely saw them in sixth grade. Um, because I always get fussed at every year. Take those down, Miss Hewing. They are terrible. They're educational. They are educational. But yes, so that is the unit that we are going to next. My favorite unit. I hate we won't be able to do our zombie attack, though. That kind of upsets me. Yeah, we can't do the crime scene either. It's upsetting too. All right. So, as I am seeing the responses, most people are saying that it is harmed. The organism is definitely being harmed by that fungus that was affecting the ants and our different populations. So, we're going to continue our conversation about these symbiotic relationships. There are three main groups of these relationships. There are some things that we've already talked about that will fit into these categories, but these are the main categories. So mutualism is where both organisms benefit. Think about mutually beneficial things. They're good for both organisms. Parasitism is where one organism benefits and the other one is harmed. Most people have heard the word parasite, which is kind of in the beginning of the word. So just think about with a parasite how you have a host that's usually the one being harmed, and then you have the parasite that's usually feeding off of the host and doing quite well. And then we have commensalism, which is where one of the organisms is going to benefit and the other one is going to be completely unaffected. It doesn't benefit nor is it harmed from the relationships that's going on with the organism. So I do have some examples for you. They are in your notes at the bottom, and we're going to talk through them, and so you know what to type in your notes. So with our mutualism, like I said, both of the things they're going to benefit from this particular interaction. Our example is going to be an anemone. An anemone. Yes. And a clownfish. So with our clownfish and our anemone, the clownfish is going to benefit from the anemone. There we go. Because it offers protection to the clownfish. The clownfish is covered in a special kind of mucus that protects it from the stings that come from the actual anemone. There we go. I've said that word so many times today. It's so hard to not get tongue tied. But it ends up also benefiting because as predators try to chase it and eat it, it can hide in the anemone and the anemone will actually kind of shock the predators, so it offers protection. Also, there are smaller fish that sometimes get tangled up in there, and the clownfish is able to eat the fish, but it's beneficial also to the anemone because the fish often drop food scraps, which the anemones can also eat, as well as kind of aerating the water itself. Because even though it has waves and all the rest of that, the anemones don't move, so it's able to kind of get that water mixed and churned up by the fish that are swimming around in it, because it's not able to move and get exposed to that fresher water. Not fresh water, like not salt water, but fresh ocean water, shall I say. Next, we have commensalism. This is where one organism is going to benefit and then the other one is not going to be affected at all. And so our example with this one is a shark and a remora. With the remora, it's going to attach itself to the shark. It's going to save energy because it doesn't really have to swim. It just kind of catches a free ride. And then when the shark eats, it also eats what the shark doesn't eat, but it is not harming the shark. It's not like a parasite that attaches to it and feeds off of the shark because the shark is eating something else. It's just hitching a ride and, eating and kind of sharing a meal with the shark. So the shark is not hurt in any way, and the remora gets a free meal and doesn't have to necessarily use the energy to swim around. Our next one is going to be parasitism. This is where one of the organisms is going to be harmed and the other one is not. So you have a loa loa worm and a human. With this loa loa worm, it does infect human bloodstreams, and it can travel all the way up to the eye of the human. We're still with the eels, really. So with our worm, the worm itself is going to benefit from feeding on the human or the host. The human can end up going blind, or it can have other complications just from the worm being in the eye. So it can be problematic. All right, so on the grand scheme of things, there are, like I said, some other examples of this, with mutualism being where both of them are benefiting. Cooperation is a version of this. And the other side of the spectrum is parasitism, where something is either going to be hurt or it's going to die. Your examples from that are going to be, for parasitism, is going to be competition and predation, which we kind of already talked about a little bit earlier today. And mutualism is going to be cooperation. You also do have some commensalism that kind of goes on there, but there are no specific ones that we've already talked about today that fit in that category. The ones we've talked about are either going to be mutualism or they're going to be parasitism. All right, so with our cooperation, they are working together so that all of the organisms that are involved are going to benefit. Our example from this is ants, because even though ants have very different jobs, all of the ants are going to work together for the good of their colony. So you have ants that go out and get food and bring it back. You have other ones that like structurally will build the anthill and the all the canals that are in there. You have the workers, the drones, you have the queen, and all those sorts of things that kind of work together, so that way their colony can survive and thrive and do what it needs to do. With competition, they are going to fight for resources. It could be food, water, shelter, or mates, like I said earlier. This type of relationship can be considered parasitism because one of them is going to be harmed in some kind of way. Our example here are with some deer that are fighting each other to be considered the best mate for a female, so that way they can have offspring. You also see this, a lot in the wild, actually, but then, like I said, they could also be fighting over resources, whereas they could fight to the death and one of them dies, or they could just fight until one of them is injured and runs away. So it doesn't always end in death, but sometimes it can. But a lot of times they just are fighting for dominance when it comes to them. Predation is where one animal is going to hunt the other for food. This is also a form of parasitism because one of them is going to be harmed, the other one is going to be fine. The one that's doing the hunting is probably going to be fine. I mean, the prey may put up a little bit of a fight. It might get a scratch or something like that. But for the most part, the predator is getting a meal and the prey is now dead. The example for this one is going to be a killer whale and a seal. The seal is definitely the prey, and the orca is going to be the predator. Not to be confused with the alien, the predator. Not the same thing. All right, so our assignment today is to go to our HyperDoc and finish our examples. So we've already done our notes through here. We are down to our examples, which are right here. What you're going to do is you are going to read the scenarios, and you can use the pictures there that are provided for you to figure out if the interaction is either, if it's mutualism, is it commensalism, or is it parasitism? What's going on? So is it that they're benefited? Is it that one's benefiting and the other one is, neutral, not being hurt or harmed? Or is it a parasitism type relationship where one of them is harmed and the other one is fine? You're going to identify which one is which by typing it in this box right here for the examples, and then you will be done with today's assignment. Once you have finished with that, I highly suggest, because the practice assignment is not that long today, that you go ahead and look at the missing assignments that you have in class and work on getting those done and turned in. My suggestion to you is that you make sure that you are caught up on all of your assignments and you've turned in everything by the time we come back from Thanksgiving break. Because like I said, when we come back from Thanksgiving, we will pick up with our new unit, which will also be our last unit for the quarter, on microbes and diseases. And the end of the quarter does come on the 21st, which you guys know, on the tail end of the quarter, it goes by really, really fast. So it would be in your best interest that when you come back for Thanksgiving, if you already have all of your stuff caught up and the only thing that you have to worry about is the new stuff that we'll be covering, which will be microbes and diseases. What you don't want to happen is the week before the quarter ends, you have 27 assignments that you need to do or finish because you started them and didn't turn them in, as well as the new material. My suggestion is we get 3 extra days after Thanksgiving break. I'm going to enjoy my days, but I do also know that one of those days I will be working too, because I know you guys are trying to step in, and I'm going to grade some of it over the break. So I don't behind on stuff as well, because it happens to get it. Yeah, I get it, because I'm behind on grading as well. I had to do some of their stuff for the science department. But so I get it. I get that we have stuff to do. However, that does not that we don't need to do the things that we have to do. So while you have some extra time today, I would definitely, once you finish your relationship practice, go through your assignments and make sure you have your stuff turned in, even if you have to do a little bit of at a time, and just make sure that you are caught up with the stuff that you need to do by the time we come back from Thanksgiving break. Would definitely be my suggestion to you. We will be in school on Monday, Tuesday next week, but then we are out for the rest of the week. So Thursday, Friday, Wednesday, Thursday, and Friday, we are out. So you do have some time that you can work on it, but I highly suggest that you get caught up and where you need to be, so that way when you come back from Thanksgiving, all of that Thanksgiving stuff is taken care of, and the only thing that you have to worry about is the new stuff that we will be doing on microbes. That would be my suggestion to you guys. All right. I get people fall behind. I fall behind too. It's okay. We're human. It happens. But the important thing is that we get caught up and where we need to be. Does anybody have questions about anything that's going on? If you're watching this video and you have questions, please send me a message in my Canvas inbox and I will answer it for you. Also, there is a updated message that I sent out today about Edpuzzle. There's been some questionable things going on with Edpuzzle, and yes, I can definitely see what activities you guys are doing in the reports, but I know that there's some people that do not have their actual name for their name. I mean, if there's a part of your name, like if your name is Justin and your name in Quizlet is like Justin 375, I can figure out who you are. But there's some people that are like Skittles 37, and I don't know who Skittles is. So there is a link to the Quizlet group, as well as instructions that tell you what you need to do as far as changing your name and how to take screenshots from here on out, just so we can alleviate some of these issues that are going on with Quizlet. So check your messages. They're in your inbox as well as on the Canvas announcements, and you can read them for yourself to know exactly what I'm talking about. But like I said, if you have questions, please send me a message in my inbox and I will answer them for you.